If you are a startup and running your Kubernetes workload on Amazon, and then this video might be useful to you. Recently, one of my contacts reached out to me who is running a fitness app asking for me a review of their AWS infrastructure. They were paying almost $1,000 per month on AWS Bill alone. What I did. And if you are more interested, the subsequent part of the video will have more detailed explanation. First, look at the infrastructure. The infra looked pretty simple. They are running an EKS workload with multiple namespace and a load balancer, and everything's being orchestrated through Jenkins running on EC2. Looks very simple, right? But here's the catch. When I get into the system, there was zero documentation, and pretty much they had no idea what is going on. So then what I did from here to this, and this diagram may look a little bit complicated, but actually it is much more simple, easier to manage. And the biggest thing is it cost 1/5 of the cost what they were paying earlier. From $1,000 bill came down to $200. In this example, I used DigitalOcean as a transformation, but the same thing could be achieved in AWS as well. So what we did, we use a simple first principle thinking, which is break down the cluster into smaller units where it's easily and manageable. Create a on-demand cluster using infrastructure as code or CI/CD. Remember, now we are in an age of AI. Generating code is easy as ever been. So use that feature and leverage it. CI/CD modernization. Jenkins is a great tool, but it is nice for a big and large enterprise, but not necessarily for a smaller company. So just move it to GitHub Action, which is virtually free. ROI. The cost they paid actually $5,000, and which actually saved them over $7,000 to $8,000 after paying everything. Full knowledge transfer and documentation, which led to them they don't need to hire any additional DevOps resources to manage it. Do developers can work by themselves. Now go to the next section where I'll break down the problem into more detail. What was the problem? So whenever I approach by similar problem, I always go to the AWS bill. Try to see for any obvious culprits, any unnecessary services which has been spin up, any obvious design pattern mistakes. Example here I saw they were running a multi-AZ database instance for a dev cluster, which doesn't need it because you need that feature in production, not in database. And of course, checking if all services are used optimally. Usual suspect, as I mentioned, they were using EKS auto mode, which is a great feature, but it may over provision what exactly needed. You can see here they are spinning up A6A machine, which may not be necessary for all the use cases. And second, running a multi-AZ dev instance Postgres DB doesn't make sense because you are paying extra for that. Third thing, I just went into their cluster, run kubectl command to see the resource utilization. What I saw, all dev, QA, and UAT instances were not used heavily. So it means they were over provisioned and they were paying for something which they are not using. These small things may be on the margin, but they actually pay long-term dividend. Jenkins was used on a last but not the least. Last but not least, Jenkins was used on an on-demand EC2, and all EKS cluster were statically created and no monitoring and logging. So what was our approach? Simple approach. First, break down the cluster into smaller multiple cluster so that you can create and destroy the cluster on demand. As I mentioned, code is cheap now. Use it and leverage it for your advantage. Second, it may be on the margin, but moving from Jenkins to GitHub saved few bucks in an EC2 instance, but also made it much more user friendly in terms of if you want to migrate somewhere. Another thing, migrating from Jenkins to GitHub was piece of a cake thanks to all AI tools. Monitoring with Grafana. Why Grafana? Grafana gives you a free up to 50 GB of matrix, which is pretty good for this particular use case. Of course, if they grow, and they may move to a much better or enterprise grade monitoring solution. But for now, this works really well. Last but not the least, documentation and knowledge transfer. I ensure that it is well documented and given to developers so that they can do it by themselves. Self-service empowerment mean create CI/CD pipeline using GitHub Action, which fully configurable parameterized so that developers don't have to struggle or maybe hire a DevOps, full-time DevOps for that particular role. Remember, if you're a startup or a small business, you may not have luxury or even budget to hire additional resource. Rapid completion, we finish the project in 4 weeks. That's it. Significant cost saving, reduce bill by 77%. If anybody is interested, please click the link below and you will get access to the testimonial with use case, detailed case study with customer testimonial. Here are the lessons. Keep it as simple as possible. Whenever possible, use serverless rather than any Kubernetes at all. If you have to use Kubernetes, use cloud infrastructure, and to deploy it, always use infrastructure as code. Thanks to GenAI, generating code has never been so easy. So why to waste time on ClickOps? Automate self-service. Whenever you are doing automation, always look for self-service to the person who will be actually using the automation, not for the person who is developing. Have some basic robust monitoring so that you know what is going on. Cost effective alternatives. There are so many SaaS services, they always give a free tier or freemium service. Leverage them whenever possible. I hope you like this video. Thank you for watching. If you have any question, please leave a comment and reach out to me or set up a quick 15-minute call with me.